Welcome back and thank you for joining. We'll continue with the lesson on Introduction to Cartesian Plane. So far we've looked at how the Cartesian plane is built. So it's the coordinate grid with a horizontal or x-axis and a vertical or y-axis that intersect at the origin. The location of any point on the Cartesian plane is easily identified by an ordered pair, which is a pair of numbers separated by a comma. The first number in the pair represents the x-coordinate and the second number in the pair represents the y-coordinate. We also mentioned the quadrants. So quadrant 1 is when both x and y are positive. Quadrant 2 is when x is negative but y is positive. Quadrant number 3 is when x and y are both negative. And quadrant number 4 is where y is negative but x is positive. We practiced how to plot points when the coordinates were given, and we practiced how to identify the coordinates when the points were plotted on the coordinate grid. Now, in the next example, we will be selecting points on the graph of a line and determine their coordinates. Now, before we start that, remember that here we are on the Cartesian plane like x and the y-axis, and what you see here is a straight line. Now, a line is made of an infinite number of points connected to each other. And as you can see, all these lines will sit on this very straight line. So when lines are sitting on a very straight line, we say that they follow a certain order. Remember, for example, when you get on the line, let's say you go to a theme park and you get on the line, there is a certain order. So the line will go this way and that way. So it depends on the shape of the line, which determines in what order the people are lined up. Now, the same thing happens with the points on a straight line. So all these points are aligned along a very straight line. So in mathematics, we say that the coordinates of each and every point in here will follow a specific rule. And this rule is what we call a relation. Before we get to the true or the formal definition of relation, let's determine the coordinates of the points A, B, C, and D. So I selected as point A, the point with coordinates negative 2, 2, point B, C, and D as indicated on the graph. And you can determine the coordinates of A by dropping A perpendicular on the x, negative 2, perpendicular on the y is at 2, which tells us that the coordinates of A are negative 2, 2. For B, x is 0, y is 1. For C, we have x equal to 2, y equals 0. And for point D, we have x equals 4 and y equals negative 1. Now, we say that a relation is a group of points that belong together on a graph or in a table of values. There are different ways to describe how the points that lie on the same line or have the same relation will form a relation. So a relation can be represented by a set of ordered pairs. When this happens, we name the relations by the letters of the alphabet, and we choose particularly the uppercase letters only. And to describe the relation, we put all the ordered pairs inside the braces, or these curly brackets. And we list all the ordered pairs, usually in order, from x equals negative to x positive. Now, a relation can also be described by using a table of values. When we use a table of values, we create sort of a t-chart. And in the first column, we list the x values, which are also called the independent values in a relation. And in the second column, we list the y values, which are called the dependent values in a relation. Now, if you decided to use the table of values by making the t-chart horizontal, then on the first row, you will have x, second row, y. So always independent first and dependent after. So x first and y after. Another way of describing a relation is by drawing the graph, by using a graph. So as you can see here, for example, the point negative 3, 2.5 will be on the graph of would be a point on the graph that is presented here. Point B, negative 2, 2, negative 1, 1.5, point C. Point D is 0, 1. Point E is 1 and 0.5. Point F is 2 and 0. And point G is 3 and negative 0.5. As you can see, all these points given in a set of ordered pairs are aligned on this line, which means that they form a relation. So they are following a specific pattern, right? And they belong to the same pattern or to the same relation. Another way of describing a relation is by using equations. So the way we do this, for example, in this particular line, if you are going 1 unit to the right, you have to go half unit down. 1 to the right, you go half unit down. 1 to the right, half unit down. So as you can see, you follow the same pattern throughout the line, and that's where the relation is, right? The relation is the x and the y are connected by following the same pattern on this line. So in this case, the equation of this particular line would be y equals negative 1 over 2x plus 1. And we'll talk more about it in the future lessons, so how to determine what the meaning of each and every number in this equation is. Now, in example 4, we have to find 2 points on the relation that is described by 2x plus 5. So what that means is that we have the freedom to choose the value of x and then determine value of y dependent on the value of x that we select. Say that we want to select x equals 1. Therefore, we're going to say the value of y will be equal to 2 times 1 plus 5. So 2 times 1 is 2 plus 5 equals 7. Therefore, we're going to say the point with x equals 1 and y equals 7 will be part of this relation. If we select x equals negative 3, then we're going to say that the y value will be 2 times x plus 5, or 2 times negative 3 plus 5, which is negative 6 plus 5, or negative 1. Therefore, we're going to say that negative 3, negative 1 will be a point on this relation. So as you can see, we connect the points, the coordinates of a point, with the equation when they describe the same relation. So in the next example, we'll connect the relation represented by an equation with a relation represented by a table of values and a relation represented by the graph. So as you can see here, we have 2 times x plus 5. So we have the freedom to choose x, and we've chosen some negative values. We have chosen 0 and some positive values. So therefore, we're going to say that when x equals negative 3, y is 2 times negative 3 plus 5, negative 1. So we say that negative 3, negative 1 is a point or an ordered pair that belongs to the relation. So you see equation, table of values, ordered pairs, and then we're going to build the graph. So we continue the same way for the rest of the points. So x equals negative 2, 2 times negative 2 plus 5 equals 1. So negative 2, 1 is part of the relation. When x equals negative 1, we have negative 1, 3. X equals 0, we have x equals 0, y equals 5. X equals 1, y is 2 times 1 plus 5, 7, so 1, 7. X equals 2, y is 2 times 2 plus 5, which is 9. And x equals 3 is 2 times 3 plus 5, which is equal to 11. So when you plot all these points on the Cartesian plane, which we are about to do now, what we're going to do is first scale the axis and then plot each and every point. As you can see, all these points are aligned. They're following an order. When we connect all these points together, you see that the line is formed. So remember that whenever you draw the line, to draw 2 arrows at the ends and to label the line by its equation. So as you can see, the same relation that exists between x and y expressed in this equation can also be described by a table of values where the x and the y are related, and a set of ordered pairs, and by a graph. So in the next example, we have something similar, but in this case, we have the equation y equals negative 1 over 2x plus 4. Try this on your own. You can do this. Thank you for learning with me. Bye for now.